for the one directional the bar element. So today, how to derive it using the this finite element method. So we are going to derive it using the principle of virtual work. So can you just put the title? Just tell me whether you are able to see the screen also. You are able to see the screen.
Yes, ma'am. Visible, ma'am.
Yes, ma'am.
Yes, will. Okay. So we will proceed. So internal work done is equal to external work done. That's a principle of virtual work. What's the meaning of internal work done and external work done? Suppose if you take your finger, you take your finger and just press it with the other finger at the end. What will happen? The finger will deflect. Am I correct? The finger is deflect. Let us take this is like a cantilever beam. That is, on one side it is fixed with a palm, and other end it is free. So it's a cantilever beam. Let us take their finger as a cantilever beam. What you are going to do is you are going to press it with the other finger. It will pull down. So when it is getting deflected, what is happening? The you are applying a load, that is pulling with the pushing with the finger is you are applying a load and it is getting deflected. So it is getting deflected by some distance. That is I have expressed that load as P, and it is getting deflected by a distance by U. That is vertical displacement. I take it as U. So this displacement I'll explain. It is a combination of, if it's a bar element, it is a one-dimensional displacement, axial elongation or shortening. But in the case of beam, it may be N1, N2, N3, N4 also. That is such a function into N1 into U1 plus N2 into theta 1 plus N3 into U2 plus N4 into theta 2. Last class we have derived. So what you have to keep in your memory is when a load is applied, the beam is getting deflected. So the load I have taken as P and the displacement I have taken as U. So why I have taken this U transpose? Suppose if you take that, this U is equal to last class we have seen. No, last class we have seen that is equal to what is that? Y n1 into y1. Do you remember n1 into when you are deriving the beam? N1 into y1, n2 is equal n2 into u theta 1 plus n3 into y2 plus n3 into n4 into theta 4. Sorry, theta 2. What is n1? Somebody can tell me the n1 value of for the beam element. N1 you have derived for the beam. N1 for the beam. Can you tell me? Somebody can read me. Read it. 1 minus
3x square by L square
3x square by L square
plus 2x cube by L cube.
2x cube by L cube. So similarly, so I can take this y1 as u1 also, theta 1 as u2, then this as u3, this as u4. It depends that the notations you can change. So n2 also you have a value. Similarly, for a bar element also we have seen the 1 hour class. For the bar element also we have seen the display. That is, this is n1. Can somebody tell me what's the value of for the bar element? This is for the beam element. Bar element, can you tell me? Last class we got derived, no?
1 minus x by n.
1 minus
X by n.
x by n. Oh, so this is a value we have derived. So so what you have to remember is that this is I can take it as u. U is equal to n1 into u1 plus n2 into u2 plus n3 into u3 plus n4 into and similarly for the this is for the bar element. This is for the bar element. So u is equal to, what you have to keep in your memory is u is equal to n into let us take this n1, n2, n3, n4. Commonly we will take it as n, and u1, u2, everything will equal to u star. U star. Can I put the summation of this one? U is equal to summation of n into u star. U star. What is u star? That is summation of, that is it is a summation. N is equal to n1 into u1 plus n2 into u2 plus n3 into u3 plus n4 into u4. Similarly, for the bar element, it is u is equal to n1 into u1 plus n2 into u2. Have you understood? N2 into U2. So because bar element only two displacements. One at the axial, one at the left end and one at the other end. Anybody is having doubt in this one, because this is a basic. This is a basic. So what I will do is, if I am differentiating this one, suppose if you take the displacement at a particular value, and if you take the derivative of this one, what will I get? That is equal to summation of n dash. That is, n dash means derivative of this, because n term consists of the x term. So I will take it as n dash into u star. Anybody is having doubt in this one? Du by dx is equal to summation of not the summation, n dash into u star. N dash into u star. That is, if it is for the whole thing, means you have to integrate and you have to find out. So anybody is having doubt in this one? If you want, you just note it down, because I'm going to erase it. If you want, you note all these things. So what you have to keep it in memory is, I told that story of the finger. I am displacing by the other finger. Can you do it, all of you? Just do it and see how it is deflecting your finger. It's like a cantilever beam, and it is getting deflected. Load is applied, it is displaced. So that's a load into displacement. That's external work done. That is, you are able to see. But something you are able to feel inside your finger. Am I correct? Some strain. Am I correct? You are applying a load. Load by area is you are applying a load over a small area. Small area. So that is the stress. Load divided by area is the stress. And what you are feeling, that is something inside your finger. Am I correct? Something, it's paining. No, when I'm getting all of it, just to do it and see, it is paining. What is that pain? That pain only I call it as strain. That is, something is happening internally, and externally also I can feel it. So that is external work done is equal rolled into displacement. That I can see externally with my naked eye. But something is happening inside, I will not be able to see. That's internal work done. That is equal to E into sigma. That is why I am using transposes. Suppose if it is how can I multiply? It's a combination of that is u1, u2, u3, u4. Then if I want to multiply it, then p1 I have to write as p1, p2, p3, p4. Like that only I will be able to write it. So that's why I'm writing. If everything is a row matrix, then I will not be able to find out the product. That's why I'm writing. One is transpose. When I transpose this one, what will I get? When I transpose this one, I will get u1 in the column direction. This will become in the column direction. That's why I use transpose, and you transpose into ut into p. Nothing, nothing else is there. So I'll repeat of this also. Okay. So you have understood something internal work done. What is the meaning of that one, and external work done? So now I can write strain is equal to, that is, suppose if I am the stress strain curve for the mild steel, you know, stress strain curve for the mild steel. And what is maybe there is stress strain curve for the mild steel is, let us take the tar steel is like this. Then otherwise you take the stress value as stress is equal stress versus strain, stress versus strain. So something is going like this, that is something is there. So if I want to find out the work done, what's the meaning of work done? Force into displacement. So what I'll do, I'll find out the area of this one. So for that, if it's a smooth curve, I can find out. Otherwise, what will I do? I will take a small strip. I'll take a small strip of that. You must study it in the BTech. It's a small strip, and you have to integrate it over a length. Let us take this is equal to, it is happening over for a B bar of length L. So you have to integrate over the length, and then if it is for the volume, then you have to integrate for the volume, like that. You have to integrate for the whole volume, like that. You have to take a small strip and you have to integrate it. That's what I have taken. I have taken a small strip and I integrated over a volume to get the total work done in a volume. Okay, so this what is stress is equal to, again, stress I can write as that is stress I can, this is, let us take this as equation number 1. So this is the primary equation. So this is equation number 1. I can write stress is equal to strain into curly bracket. I told you, if it's a vector, I have to use the curly bracket. So E into stress is equal to E into strain. Am I correct? C into strain. So that is, you know now, that is what's the meaning of stress by strain is a constant. That constant we know as Young's modulus. So stress is equal to strain into Young's modulus. Strain into Young's modulus. Strain has got also a value, that is a positive strain or a negative strain. That's why I have written like this. Then, so can I substitute the value of the stress here? If I can substitute the value of strain, and before that, I want to find out the value of what is E. So now I have written the expression for the stress. I will write for strain. Strain, I told what is strain. Strain is equal to integral of integral. I have put it here, so I will not put the integral here because I have taken strain is equal to du by dx, that is equal to u. What is u? Already I have told, you know, u is equal to n into u star, that is d of n u star divided by dx. So that I can write as, when I differentiate this one, I'll get it as n dash r dx. Otherwise, I can take n dash as beta. N dash as, that is n dash is the derivative. So that is beta is the derivative of n. Beta is the derivative of n. So just copy down. After this one, you copy down. So the strain I have taken as beta into u star. Anybody is having doubt in this?
No, no.
Yeah. Okay. Then we can proceed here. What I'm going to do is just substitute the value of our sigma E, I know the value of sigma, I know the value of E, I'm going to substitute here. Similarly, U, I can take it as U is equal to, what is that? U is equal to, U, what did it, well, you have to know that U also, that is, U is equal to, somewhere I can write here, otherwise, before that, U is equal to N into U star. N into U star. This also note it down. Now you know the value of E. Let us take this is equation 2. This is equation 3. Equation 3, or you can take it as this is equation 3 and this is equation number 4. So what you have to remember is, you have to remember the expression for the internal work done is equal to external work done. Then stress also already I know. Stress is equal to sigma what is the Young's modulus into E, that you have studied already. And U is just now I have told, no, U is equal to N1 Y1 plus N2 Y2 plus N3 Y3 like that. So I am writing as U star, and strain is equal to du by dx is equal to this U I am putting it here. So I have to differentiate this one. When I differentiate N, you will get N dash. That N dash only I have taken as beta. If you want, very well keep it as N dash also. Because it's the usual notations in the book, it is used as beta. We will take it as beta. So now I'm going to substitute all the values of sigma, E, everything in the equation 1. So substituting the value of sigma and E into equation 1. What will you get? That equation, what will you get? E is equal to beta into U star. That is, I'm going to substitute everything in the first equation. That is, so this is the equation, first equation. Can you tell me the E value? E is equal to, so that is equal to integral volume into E is equal to beta into U star, beta and U star, that is a transpose, beta and U star. So that is the transpose into stress is equal to Young's modulus into strain, Young's modulus into stress is equal to Young's modulus into strain. Again, strain is equal to beta into U star. Am I correct? Already you have this equation, we have E transpose. Then sigma also you have E into E. So the value of E is equal to beta into U star. So I have to put the value of E into U star. E into small e is equal to, again it is beta into U star. Beta and U star. That is equal to that is if when you are integrating that, dV, that is the external work done, internal work done is equal to external work done. External work done is equal to, what is that? Integral, again it's a volume, that is, have you noted this one? Should I wait for you?
Yes, ma'am.
You're right, written, no, okay. Then this is equal to U transpose. Again, U transpose is, we have taken U is equal to N into U star transpose P into dV. So putting all these values you are getting here are beta transpose U star transpose. You can put this then E value into beta into U star into dV. The whole thing you have to integrate. It's equal to integration of V into N transpose U star T P into dV. You have to be careful. This is N transpose and N dash transpose only. N dash we have taken as beta. N dash is nothing but the derivative of N. Derivative of N. So can you take the commonly outside this U transpose from here? You can take it as here and you can take it as. When you take it, it will get cancelled. Finally, you will get beta transpose E into beta into U star into dV is equal to integral P into N transpose P into dV. So when you integrate this one, what do you understand from this one? This term, when you take this term, this is, if I take this as K, we have taken, in the case of frame, R transpose KR. Do you remember R transpose K into R? Like that, beta transpose E beta. If I take this as K, and this, then my equation will become, this is equal to K into U star into dV is equal to integral of N transpose P into dV. Have you copied down? Any doubt in this one? Because this is a basic equation you have to remember. Any doubt? Anybody? Should I explain one more time, or it's sufficient for you? I want to hear from all the people. Kaviyarasu, is it okay, or should I stop anywhere? Hello, Kaviyarasu. Hello.
Yes, ma'am.
You understood, or?
Yes, ma'am.
You
Understood,
understood.
ma'am.
Okay. So this is K is nothing but B transpose E into B. This E we call it as constitutive matrix. E is the constitutive matrix. If you want, I like write the explanation also for that. E is the strain matrix. E is the strain matrix. Strain matrix. Beta is nothing but the N dash, no? N dash. N dash is the beta. Beta is the strain displacement matrix. And U star is the degree of freedom. Degree of freedom. Okay. So I can write very well. That is, what is that? 1 minute. Integration of V into KV into dV is equal to N transpose P into dV. This is nothing but Ku is equal to P. Ku is equal to, this is Ku, it's over a volume, and Ku is equal to P. K is equal to P. Now we are going to find out the displacement matrix for the stiffness matrix for the bar element. First we will see for the bar element, then you can do it for the beam element. For the bar element, if you are taking, so I'll take the value of beta transpose E into beta, that is equal to that is equal to that you have to find. You are going to find out the value of beta transpose E into B. 1 minute. Now we are going to derive for the 1D bar element. Bar element, we are going to derive the stiffness matrix. Okay. So what is the for the bar element? For the bar element, N1 is equal to, already we have learned N1 is equal to 1 minus x by L, 1 minus x by L, and N2 is equal to x by L. So can you find out the value of N1 and N1 dash and N2 dash, N1 dash and N2 dash? So when I differentiate, I can put like this: beta is equal to d by dx of n. What is n1? That is n1 minus x by L, comma x by L. Can I put like this? Because n matrix is n1 plus n2, n1 plus n2. So that alone I have taken. And can you differentiate and tell me, when you differentiate this, you will get, what will you get? Minus 1 by L, and this is plus 1 by L. So that is equal to minus 1 by L, comma plus 1 by L. So we have found out the beta value. Then now we are going to find out beta transpose. Did I mention the word E instead of V as D matrix? Okay. Beta into E into beta. Can you tell me the value of this? That is beta transpose. That is minus. You have to transpose. This is beta value. You have to transport it. Minus 1 by L. 1 by L. Then E into minus 1 by L. Sorry, this is transpose. Transpose means 1 minute. You have to, when you are transporting it, transposing the operation using the you have to 1 by L. 1 by L into minus 1 by L. So can you multiply and tell me? I can take E outside. What will I get? And then multiplying by the first row, first column, that is 1 by L square. 1 by L square. Then first row, this is over. First row, second column, that is minus 1 by L square. This is this into this, that is minus 1 by L square and plus 1 by L square. Am I correct? First row into first column, then first row into second column. That is over. Then next one, second row into first column, second row into second column. So I got this value. So can I take the commonly the values outside? E into 1, minus 1, minus 1 and 1 by L square, by L square, by L square. So now what I am going to find out, I have to find out the integral value of this. Am I correct? Integral value of integral value of beta transpose E into B into U star into dV. So integral I have to find out. So integration of beta transpose E beta, it is over the volume. Here it's a linear element, so let us take its area into dx. That is equal to beta transpose E into beta into area into dx. Volume is equal to area into distance. So I will take that this, and when I try to substitute the value of beta here, what will happen? We have already found out the value of beta transpose E beta, that is E by L square. E by L square into 1 minus 1 minus 1 1 into integral of this a also I can take it as integral of dx. So integral of dx, it is varying from the distance, it is L. This is L over the length. And that is equal to AE by L square into, when you are differentiating, this is 1 into dx. Am I correct? 1 into dx. Integral of 1, what is the value? Integral of 1 is equal to x. So when you are substituting the limit, you will get the value of L. That is x, the limit, we will get the value of L, that is L minus 1 and 1. Sorry, minus L. So this L commonly, if I cancel it, what will I get? AE by L 1 minus 1 minus 1 1. Do you remember this is a stiffness matrix? Stiffness we have derived in the when you are studying the matrix method itself. This is the stiffness matrix. This is the K values. If you want, you can take it as beta transpose is equal to K. K is equal to beta transpose. So that is equal to AE by L minus 1 1. That is a this is for the bar element. That is for the bar element. So for the bar element, K is equal to A by L 1 minus 1 minus 1 1. So this is the stiffness matrix. So similarly, you can go for the this, what is that? beam element also. You can do it at home. That is, you can do it. What you have to do is, you have to, here I have taken, what is the difference? That is a homework for you, and you have to upload as a assignment, and you have to check it. That is, what is the n1 value for the, here I have taken the bar element. So once again, should I repeat it? That is the derivation of the stiffness matrix for the one dimensional bar element. That is the use, we are using the principle of virtual work. That is the best example I told us. You just deflect your finger and see. That is, something is deflecting that you can see with your naked eye, but some pain you are feeling inside, some internal work is being done. That we call as strain. That is, your the flesh, muscles, bones, everything is getting stretched. That is, stretch means it is undergoing some part of strain. So stress into strain is equal to load into displacement. That's a you might have studied this one in the BTech itself, the principle of strain energy. When you are studying, you might have studied all these things. So when you are integrating over the whole volume, you'll get the what is internal work done and the external work done. And two more things you have to remember. What is stress? Stress is equal to Young's modulus into E, and E is equal to nothing but the differentiation of du by dx, and u is equal to n into u star. So when you are differentiating the n, you will get n dash. That n dash we have taken as beta. So you have to remember the n dash is equal to nothing but beta. N dash is nothing but the beta. So substituting the value of E into the primary equation, you stress also got a value of strain. Already there is a strain value. When I'm substituting that, I'll be able to get the when I'm simplifying that I'll be able to get the equation like this: beta transpose E into beta into u star into dv is equal to integral of v nt p into dv. So this is nothing but k, because we know k is equal to p. That's the equation. That is k, already we have studied, no, k into u is equal to p. So when you compare this one, you will get k is equal to nothing but beta transpose E beta, and p is equal to n transpose p. So I'm going to find out the stiffness matrix for the bar element. When I'm finding the stiffness matrix for the bar element, I will get the value of n1 is equal to 1 minus x by L, and n2 is equal to x by L. So beta is equal to, you will be getting, you have to find a differentiation of this shape function. This is the shape function. When I am differentiating, I will be getting this value minus 1 by L. So once this beta is obtained, I'll be able to find out beta transpose E beta. So when I simplify this, I'll be getting the value of, what is that? AE by L, 1 minus 1 minus 1, 1. This is for the value for the bar element. Okay. So similarly, you have to do it for your beam element. What you will take for the beam element, it is n1 is equal to, somebody help me, 1 minus some value. Then n2 is also there, n3 is also there, n4 is also there. So then you have to find out beta value. You have to differentiate that one, and you have to find out the value. Then you have to multiply and you have to find out. That is, when you are finding out, that is in the shape function, you will have the value of slope and deflection. So you have to, beta is nothing but d square by dx square. D square by dx. So you have to differentiate twice. Here d by dx, and there you have to differentiate twice. So that's a difference. Then I think with this we will stop. And when you're finding out the value of k, in the case of stiffness matrix for the beam element stiffness matrix for the same value only you will be getting. What you have learned already in the first unit, 12A by L cube, 6EI by L square. Is it minus? Minus 12EI by L cube. Six EI by, somebody can help me. This one. Can you read the value? When you are doing that one, you will get the same value. Same value. Can you tell me the value of this second row? Jagan, 6EA by L square. Then Jagan, can you read it? What's the value? Hello?
Yes, ma'am.
Somebody read it. 4EA by L. And this is it
6EI minus 6EI.
minus 6EA by L square. Then 2EA by L. Then this is
Minus 12EI by L square. Sorry, L cube.
L cube. Then 6A by L square.
Minus 1.
Minus, yeah, minus. Here it is 12A by L
12
cube.
L
A
square.
by
L
L
cube.
square. L cube. And 6A by. Is it plus or
Minus
minus?
6.
Minus. Yeah, okay. Then here it is. What is the value?
Minus 6EI by L square.
Yeah. Here it is 6A by. No. It is 6A by L square. 6A by L square. Then this is 12A by 4A by L. Oh. 2A by L. Am I correct?
Yes, ma'am.
Yeah, 2EI by L. And this is 6 minus 6EI by L square. 4EI by L. So this is the value for the bar element. So this is a K value. So when you derive this one, you will get this value. Okay. You get the value of the stiffness matrix. So whatever you have derived in the first the first class, that is the first unit, the same thing you will be getting. That's the meaning of that one. So we will do, time is there, no, 45, 10 more minutes. You take a problem, you can do it at an assignment. So find out this is assignment. Already we have done assignment 4, no, assignment 5. Assignment 5. Check down the diagram. And the span is 1 meter. E is equal to 210 into 10 power 9 square, and I is equal to and power 4, 6, 7 power 4. Find the rotation at B and C. Okay, this is A, B, C. So what you have to do is you have a seminar hour today, no? And that seminar hour, I'll be taking that, and you have to do this assignment and submit it within 2 days. That is, you have to find out the stiffness matrix. K is equal to P. That only you have to solve it. K is equal to P, and you have to find out the value of U, because A you will have U1, U2, U3, U4, U5, U6. But the other things, that is here if you take this is rotation is it's a fixed chain, there will not be any rotation, no translation. Here no translation, but rotation will be there. So that's what it is asked. Theta B and theta C, you have to find it out. So in the seminar hour you can do it. This assignment you can do it. Same procedure only the way we are deriving the stiffness matrix is different, but all the other things are same. So this stiffness matrix only you are going to find out. You have to exactly do as you have done it in the matrix method. That is, since suppose if I ask you to find out the rotation at in between, let us take this point as A1. If I ask you to find out the rotation, then that point you have to consider one node. So wherever you want to find out the displacement, you have to introduce one node. Since I have asked the rotation at the end, you need not introduce any node. It seems like it is like what we have done in the first unit. Suppose if I want to introduce one more node here, that is, I want to find out the deflection between this beam, then deflection or the rotation at this beam, then I have to introduce the node at that point, and I have to consider as a separate element. So that's the difference between this and that one. So do this problem as your assignment. This hour is up to 9:57, 10:50. So I think I will stop at that. And you have any doubt means you can ask in the seminar hour.